The two main objectives of altimeter setting procedures are to provide adequate vertical separation between aircraft and provide adequate terrain clearance during all phases of flight. There are two altimeter subscale settings that can be used at any aerodrome. QNH, this is the observed barometric pressure at an aerodrome, adjusted in accordance with the ISA pressure lapse rate, to indicate the pressure that would be observed if the observation was carried out at sea level. If set, therefore, the altimeter reads aerodrome elevation above sea level. QFE, this setting is the observed barometric pressure at ground level on an aerodrome, which if set on the subscale, will cause the altimeter to read 0. When an aeroplane is flying at altitudes at or below the transition altitude, the aircraft is flown at altitudes determined by reference to sea level pressure, QNH, and the vertical position is expressed in terms of altitude. Above the transition altitude, the aeroplane is flown along surfaces of constant atmospheric pressure, based upon an altimeter subscale setting of 1013 millibars, and this altitude is expressed in terms of flight levels. During a climb, upon reaching the transition altitude, 1013 millibars is set on the altimeter subscale, and the climb continued to the desired flight level. In descent, upon reaching the transition level, the QNH is reset, and descent continued to the desired altitude. The flight level 0 is located at the barometric pressure level of 1013 millibars, and all subsequent flight levels are separated by pressure intervals corresponding to 500 feet in standard atmosphere. They are numbered flight level 30, flight level 35, flight level 40, flight level 45, or, as they get higher, flight level 100, flight level 105, flight level 110. The last two zeros of the number are always omitted. The transition altitude is to be specified for every aerodrome by the state in which the aerodrome is located, and shall be as low as possible, but normally not lower than 3,000 feet. Transition altitude will be calculated and rounded up to the nearest 1,000 feet, and published in the nation's AIP and shown on charts and approach plates. In the United States of America, for example, the transition altitude over most of the country is 18,000 feet, but it is higher over the mountains. In New Zealand, it is generally 13,000 feet. Remember that the transition level is the flight level at which the altimeter is reset to the aerodrome QNH on the descent. Subsequent flight is reported with reference to altitude. It will normally be passed to you in the approach and landing clearances. It changes with QNH changes, and is calculated by the controllers at regular intervals. It is defined as the first flight level above the transition altitude. Also, don't forget that the transition layer is the airspace between the transition altitude and the transition level. It is usually insignificant. When ascending through the transition layer, vertical position is reported as a flight level, and when descending, it is reported as an altitude. Before commencing an approach to an aerodrome, the pilot is to obtain the transition level. Before descending below the transition level, the latest QNH is to be obtained. QFE may be used by a pilot so that he may obtain terrain clearance information during the final approach to a runway. When cleared to land and with QFE set, the OCA or H may be calculated with reference to height above the aerodrome datum for that portion of flight. It is standard format on approach plates that all vertical displacement is shown as both AMSL and AGL. This conversion is illustrated here. You will notice that AMSL is printed in bold type, with AGL in brackets.